So we started Unit 3 today. So this is Lesson 1 of Unit 3, which is on factoring. So we started with this example. So we know that step 1 of factoring is always to check for greatest common factor. And if there is one, factor it out. So looking at this first problem, 6x squared minus x minus 2, there is no GCF. So then I'm going to go about factoring it. Now, depending on how you were taught, there are lots of different ways to factor trinomials. So we have 3 terms here. We already checked for GCF. I'm going to show one of the techniques that you may have been taught. If you like to use this technique that I'm going to show, that's fine. Or if you prefer a technique that you were taught before Algebra 2, that's also fine. But I'm going to use the diamond. And using the diamond, basically we're going to take the leading coefficient 6 times the constant -2, and that gives us -12. That's the top of the diamond. The middle term, basically all I really want is the coefficient for that middle term, -1 is the bottom. So I'm thinking of factors that are going to multiply to 12, specifically -12, and add to -1. So I know 4 and 3, and then sign has to be negative for the 4 to add to a -1. So if this was a 1x squared, I'd be done and I would just say x minus 4 and x plus 3 were my solutions, the factors. But it's not a 1x squared. So because it's something besides a 1x squared, I'm going to move next to the generic rectangle. In the generic rectangle, we put the first term in the first box and the last term in the last box. The other 2 values from our diamond, -4 and 3, go in the other 2 boxes, and the order there doesn't matter. I look here to my middle term, it's an x, so I know I need to put x's with those. Whatever that variable is goes with those numbers. So now I'm ready to factor across the rows and down the columns of this generic rectangle, pulling out the greatest common factor. So across the first row between 6x squared and -4x, 2x is the GCF. Across the second row, between 3x and -2, +1 is the GCF. Down the first column, between 3x and 6x squared, 3x is the GCF. And down the last column, between -2 and -4x, is -2. If they're both negative, you want to pull out a negative. Now, to check that, you should multiply to see if you get what's inside the boxes. I'm not allowed to change what's inside, but I am allowed to change what's on the outside if it doesn't end up working correctly. So 2x times 3x should be 6x squared. It is. 2x times -2 should be -4x. It is. 1 times 3x should be 3x. Yes. And 1 times -2 should be -2. So that's how I know that the factors are 2x plus 1 and 3x minus 2. And we know with multiplication the order doesn't matter, so I could have had those in the reverse order. So that's how we factor a trinomial. Okay. Next problem. This one's also a trinomial. I am going to check first for GCF. I don't see one. So because there's no GCF and it's a trinomial, I'm again going to go to a diamond. Leading coefficient 1 times the constant on the end, -6, gives me -6. Bottom is the middle coefficient, which is a 1. So I'm thinking factors of 6, -6 are going to add to +1. I know 3 and 2. And I know that the negative should go with the 2, so that when I add 3 plus -2, I get +1. So this is a 1x to the 4th. Now it's to the 4th rather than squared, but the leading coefficient's a 1. So I do not need to use a generic rectangle. I can go right to my 2 binomials. And I'm going to put +3 and -2 on the ends. And now I just need to think here, that's going to give me the -6, which I have, but I also want x to the 4th now rather than x squared. With x squared, we know it's x and x, so with x to the 4th, we know it's x squared and x squared. And you can certainly multiply that out, doing first times first, outer times outer, inner times inner, last times last to check it. And when you do, you'd have a -2x squared and a +3x squared from the outers and the inners. And when I combine those, I am getting the 1x squared. So I know it's correct. Now I just have to check x squared plus 3. That's not factorable because it's a plus. X squared minus 2, that's almost difference of squares. However, 2 is not a perfect square. So it does not factor further. X squared plus 3 times x squared minus 2 is my final answer for the factors. Number 3. So we always check for GCF first. We see 3x is a GCF. So I pull that out. When I pull that out, I'm left with 3x times x squared is 3x cubed, and minus sign 3x times 4 is 12x. This time I'm checking that I see two terms, minus sign, and both terms are perfect squares. So that means this is difference of squares. If you recall how to factor using difference of squares, one is a plus and one is a minus. Take the square root of the first term, so x, and it goes in the first spot. Take the square root of the last term, 4, which is 2, and it goes in the last spot. So x squared minus 4, using difference of squares, factors into x plus 2 and x minus 2. So this is my final answer for the factors. Next example. So I check for GCF. I don't see one. I see two terms. So two terms means I don't need a generic rectangle or a diamond, but again, I'm going to check for if the two terms are perfect squares because I see that minus sign. So 25 is a perfect square, x squared is also, and 16 is also. I can go right to the binomials. One is going to be plus, one is going to be minus. Square root of 25x squared is 5x, and the square root of 16 is 4. 5x plus 4, 5x minus 4. Next, first check for GCF. I don't see any. Trinomial, 3 terms, means I'm going to make a generic rectangle possibly, but definitely a diamond. So 1 is the leading coefficient times -8 gives me -8, and the middle coefficient is -2. So I'm thinking factors of -8 that are going to add to -2. So I know 4 and 2. More specifically, the sign needs to be negative for the 4. So now I'm going to go and see if I need to make a generic rectangle or not. Leading coefficient's a 1, so no need for a generic rectangle. So I'm going to go ahead and make my 2 sets of parentheses for my 2 binomials. I'm going to put -4 and +2 because of these. We already talked about that x to the 4th comes from x squared and x squared. But I have to check one other thing here. -4 times +2 is -8, not -8y squared. So I know, because I'm missing the y squared there, I know I'm going to need a y and a y. And again, if I wanted to, I could check that by multiplying. When I do the outer, I get it 2x squared y, and the inner -4x squared y. When I combine those, I would get a -2x squared y. So it works. So now I have to check this to see if it's factorable further. The second's a plus, so no. This almost, you have to be real careful, this almost looks like difference of squares. However, the -4y is not just a -4, which is a perfect square, and it's not a -4y squared, which is a perfect square. It's a -4y. The y is not squared, which means it's not perfect square, which means I can't factor it further. Had it been x squared minus 4, then I would factor further using difference of squares. Had it been x squared minus 4y squared, then I would factor further using difference of squares. It's neither of those, which means it's not factorable any further. Next one. So again, we're going to first check for greatest common factor. This does have a greatest common factor of 3. Factoring that out, I'm left with 8x squared minus 2x plus 5. Next, I'm going to see if this trinomial factors. So 3 terms, trinomial means I'm going to check with a diamond. 8 times 5, 40. Be careful with that. It's 8 times 5, not 24 times 15. Okay, you don't want to use the original. You want to use the trinomial that we're trying to factor, the 8 and the 5. And -2 is the denominator, or is the bottom. So I'm thinking through my factors. 40, 1 and 40, 2 and 20, 3 doesn't go in, 4 and 10, 5 and 8, 6 and 7 don't go in. Now I'm at 8. So those are the list of factors. If I check each one of those sums, none of them are going to give me -2. So that means that this trinomial 8x squared minus 2x plus 5 doesn't factor. So if it doesn't factor, then I can't factor this any further. That would be my final answer. Next one. Once again, checking for GCF. I do not see one. It's a trinomial, so I'm going to go ahead with a diamond. 1 times -14, -14. Bottom is the middle, -5. So factors 7 and 2. Sign has to be negative on the 7. So I do not need a generic rectangle because it's a 1x squared. I can go right to my answer. So I'm going to go ahead and write the x because I see x squared, so x and x. And -7 and +2. But I'm going to look here and I see y squareds, so I know I need y's. Checking that, looks like it does not factor any further. That's my final answer. Next. Okay, now all the previous problems we did not involve fractions in the original problem. So notice none of those had fractions in the factors. Okay, and that's always going to be the case. The only time you're going to have fractions in your factors, in your answer, is when there are fractions in the original problem. Okay, so factoring generally does not involve fractions. But if there's fractions in the original, then we know that it will. So I'm looking here and I see the greatest common factor between 1/4 and 9/4 is 1/4. So I'm going to factor that out. When I factor it out, I'm left with x squared minus, and I'm thinking, what do I multiply 1/4 by to get 9/4? That's 9. And then I still have the y squared there. So that's my first step. After I pull out the GCF and I'm left with x squared minus 9y squared, I'm checking to see if that factors. So I see two terms. I see a minus sign, and I see perfect square, perfect square, perfect square. So this is difference of squares. So I copy my 1/4, I make two binomials. I'm taking the square root of x squared, which is x. One's going to be plus, one's going to be minus. The square root of 9y squared is 3y. And that does not factor any further, therefore that's my final answer. Next, 3/4 x squared minus 12/25. This is similar to the last one we did. There is a GCF, but it's a little different in that if I'm looking at the denominators, in the last one we had 4 in both. So we knew 1/4 was the GCF. Here, not only do we not have the same denominator, 4 and 25, but if I think of factors of 4, 1, 2, and 4, and factors of 25, 1, 5, and 25, the only common factor between them is 1, and 1 doesn't count. So I know that this time my GCF is not going to involve a denominator in common, which means it's not going to involve a fraction. The greatest common factor here is going to involve the common factor between the numerators, not the denominators. So my greatest common factor is going to be a whole number rather than a fraction. So I see between 3 and 12 that 3 is the greatest common factor. So now I have 3, and I want, and I can just put that over 1, and I want to multiply it by something to get 3/4. So I know 3 times 1/4 gives me 3/4, which means 1/4 x squared is the first term. Then I'll copy the minus sign. Now I have 3 over 1 times something, and I know that I want it to equal 12 over 25. So I know the 3 has to be multiplied by 4 and the 1 has to be multiplied by 25 to give me 12 over 25. So 4 over 25. So now I'm checking to see if that factors further. Well, I see two terms. I see a minus sign, and I see 1/4. 1 and 4 are both perfect squares. X squared is a perfect square. 4 and 25 are both perfect squares. So this does factor further using difference of squares. So I keep the 3. I make two binomials. 1 is plus, 1 is minus, and I'm going to take the square root of each of these terms. So the square root of 1/4 means the square root of 1 divided by the square root of 4, which means 1/2, 1/2. Square root of x squared is x. So I have 1/2 x as the first term in each of those. Now, the square root of 4 is 2, the square root of 25 is 5, so the square root of 4/25 is 2/5. So I have 3 times the quantity 1/2 x plus 2/5 times the quantity 1/2 x minus 2/5. That does not factor any further. That is my final answer. And the last problem. So again, check for GCF. I see 6. Pull that out. I'm left with y squared minus 5. I see 2 terms and a minus sign. However, 5 is not a perfect square. Therefore, that is my final answer. Homework. You should complete in the worksheets booklet in Unit 3. Make sure you go to the correct unit. Unit 3 we're in now, worksheet number 1. In the worksheets booklet, Unit 3, worksheet number 1 is for tomorrow.